Hi friends, welcome to follow up. Let's have a look at problem 1247, minimum swaps to make strings equal. This is also a daily challenge problem. So in this video, we're going to analyze the strategy and demonstrate to you that starting from example 1 and example 2, actually we can derive the counting or the result for general case. So without further ado, let's first digest the problem requirements, and then we look at the analysis, and finally we share the coding. So now for the analysis or digest, so we are given two strings, S1 and S2 of equal length, consisting of letters X and Y only. So our task is to make these two strings equal to each other. We can swap any two characters that belong to different strings, which means we swap, right? Pick one letter in the first one, swap with another in the second one. So we want to find the minimum number of swaps required to make S1 and S2 equal. Otherwise, we return -1 if it's impossible to do so, right? So if you look at example 1, so you know if this such a pattern, right? You have X or some adjacent or not, and then you have YY, right? So in this case, you just need one operations as in the explanation here, right? So if you have the scenario in example 1, so here you have one X, you have one Y, so maybe adjacent or maybe not, but their corresponding indices are the same. So in this case, we need two operations. So we need one operations to reduce to the case for example 1, and then need another swap to make them equal, right? So we need two. And we actually can see that the generic case, if it's possible to make them equal, is to be covered by example 1 and example 2, right? So the example 3 is actually we return -1. This we regard as edge cases. So here we have 3x, we have 1y, right? It's impossible to evenly distribute them because 3 or 1, you just need to check 1 is odd number, right? So here the constraints are the following. So their lengths are the same, and they both contain only x and y. So these two are consistency assumptions. The first one is about the problem size. So the length, because their lengths are the same, so the length is bounded above by 1000. It's very small, problem. So with that said, let's look at the strategy. So what we are going to do is to count indices where the corresponding characters do not match. Let's see. And then we use pairing given by example 1 and example 2, right? So note that if any of the total counts of x or y's in the two strings is not even, then we just return -1, right? Otherwise, we try to find count pairs like this, because this requires less operations. And if, for example, you have 3x, right? You have 3x, and you have another one. Let's see. We have y, and you have y. So this is impossible. But if you have this kind of thing like this x, y, and this x, you try to count the number of x, and then you match and y's, right? Here you just one operation. For these two, you just use two swaps, right? So that's going to be our strategy. So for coding part, and you have lots of freedom. So you can write a very short code, or you can write a slightly long code. But here we are going to take a strategy that we just translate the above analysis into coding format. I guess later you can do some simplifications or optimizations. So here I'm going to concatenate these two. I want to first exclude all the cases for example 3. So if s count the number of x over 2 is not So it's not 0, or you can say it's equals to 1, or as count, so this y modulo 2 is not 0, right? Then you just return -1, because you cannot evenly distribute them, because the result will have equal S1 and equal S2. So the number of x and y should be even. So this is the one case. So next we're going to count the indices where the characters do not match. So this actually is super easy, but here let me introduce some comprehension. I'm also going to use a zip function. So for I, AB are the characters in enumerate. So we use enumerate because we are interested in the indices, and then also we want to compare the corresponding characters. So we're going to zip S1 and S2, right? So here, if A does not equal to B, so we're going to collect those indices. And then we want to see for those indices, how many x we have, how many y we have. So this is just another count, right? Or you can just use, say, a for loop. Anyway, so let me in x and y equals 0, 0. So you can call some built-in function, or it's just a simple for loop for I in indices. Let's see. If S1I is x, it means S2I must be y, right? So the count of x is increased by 1. Otherwise, the count of y is increased by 1. So now we have those x and y's, and then we want to count the pairs of x and the pairs of y, right? And then we just assign them the corresponding number of operations, either 1 or 2. So now let's do C1, R1. Let's use the dev mode. So nx, let's say nx divided by 2, right? And similarly, C2, R2, or C, you can change this 1 to be x and the 2 to be y. It's more suggestive. So here I'm use ny and the 2, right? So you have C1 pairs of x, right? So we just need this number of operations. And you have C2 pairs of y in S1. We need this pair of operations. And then we're going to do C1 plus C2 if R1 equals 0. Actually, if this equals 0, C2 must also, R2 must be also 0, because we have excluded this situation, right? Otherwise, we are going to return C1 plus C2. This is pairing this kind of formations. And then you have one, either you remain an x, then you will have x and y, right? Here you have, so you have one x left, you must have one y left. In other words, you will have an xy in the first string, and then you will have yx in the second string. But this need 2 operations, right? We're going to add this 2, right? In other words, we need at most once for this kind of operations. Most we want to use this one. So now let's do a test. List object cannot be let's see, for I in range. So I see. So for I in indices, I read too much range. So yeah, it passes one example. Now if you look at example 2, so let's see, if it can pass this one, all right? So as we mentioned, we will pass generic case. Let's see. And let's also test S1 is XX, and this is XY, right? So the edge case. The return is right. It means that this logic plays a role, right? And then the first 2 examples indicating the logics here are right. So now let's look at the generic case. Yeah, it passes all the cases, So here I would say this actually is not necessary, even here. But you just need to use the for loop to count the indices corresponding to the differences, and then count those and compute this. But I read in such a format. In other words, with redundancy. but the purpose is only for pedagogical purpose. It's just for the ease of understanding. You have lots of freedom to modify the code, but the main point is to digest the thought process. So with that said, I guess that's basically about it. Thank you.